Hello guys, welcome to CWP. Well, we're happy to have you here today. If you're just joining us in this class, you pretty much want to go and watch the other class at NumPy where we started, we discussed about the NumPy functions, so you can get a better understanding of what we're going to do today. I'm going to post a link right up there so that you can just click on it and go watch it and then come back to this one so you can understand everything that we're going to be doing here today. With that being said, yes, today we want to build a simple model, not really crazy model, but just it's just a sample model for us to understand really, for us to really understand that it's possible to use NumPy to create these things. It is more like what is going on under the hood kind of like tutorial, so that you understand it's not just looking at somebody from the outside. You want to know the character of the person. You want to know how the person acts when they're out there, when they're inside their house, because charity begins from home. All right, with that being said, let's get right into what we have today. So the things we're going to be learning today, to create, we're going to create stuff like we're going to talk about stuff like, representing your data, which just creates a simple kind of like a matrix data to get our feature and our column. We're also going to talk about, initializing weights. I'm going to teach you how to do that. And we're also going to talk about how to make predictions, right? The math behind it. We're going to talk about, calculating errors. We also going to talk about compute loss. We also going to talk about gradient descent, and as well as just go a little bit inside gradient descent, tell you what it is, why we use it in machine learning and all that, the formula. And we're also going to finally go into how we can update this different weights, right? And then finally we are going to talk about the training loop. Right? A training loop is basically everything as a single entity. Now think about running it a lot of times so that your machine learning model can learn from it. That's what the loop is doing. So it's just like repeating the whole step over and over again. Right? So yeah, with that being said, let's get started. Well, the very first thing here we want to get, it's like, let's talk about what, let's just describe what machine learning is, first of all, because a lot of you, this probably be the first video you're watching about machine learning. So I'm just going to go ahead and just tell you what machine learning is, and we can just take it out from there. All right. So machine learning is a mathematical operation, operations applied on data. So it's not really a big deal. That's not a long definition. I know some of you were expecting a longer definition, but that's not what it is. It's just, a mathematical operations applied to data. So data is kind of like the heart of machine learning. Without data, you can't have machine learning. And NumPy, actually, just like we said in the previous tutorial, is numeric Python, stuff, mathematical Python. NumPy handles those operations, actually. As a matter of fact, it handles them efficiently. Let's get into the first thing we have today. The first one is representing data. But before we start that, I want to create a new file here. I'm going to call this first ML. That's your first model or first machine learning. That's the idea to this name. All right. So we create a new file right there. And then the next thing we want to do is to start. So let's import NumPy first of all. And like I said, if you haven't watched the previous tutorial, this might be a little confusing to you. So you might want to pause right now. I'm putting a link up here again so that you can go back, watch NumPy, and then come back so that you can get follow up properly. All right. So we have not imported NumPy, and we're going to import that as NP. All right. So let's have our data here. I'm going to go there and just call NP array. We already know what this is, and I'm just going to create, this is a matrix. I'm just going to give 1, 2. This is a simple data, actually, so we don't want to do too much because we are trying to get the basics here. When you understand the basics, now you can play a lot around with it, okay? So we're just going to have 3 here, and 4, all right? So if we have that, very good. Now we declare a matrix for our data, right? So our training data represents a future matrix and a target vector, right? As a matrix and matrix containing vectors, pretty much. Do you understand it? Each row is a data sample. Each of these rows, they sample, and the column is more like, the future. So Like we said in the NumPy, in other tutorials, we can have houses, and price of houses, land size, and all that to be your features and all that. But that's not what we're talking about in this tutorial. We just want to focus on how you can create your machine learning, model from scratch. And this is a linear regression, actually, just in case you're wondering. Okay, so having a matrix right here, we have that here. And so we're going to create our output here, which is our Y. Our matching output is going to be an array as well. Like I said, everything NumPy is more like array. So think of it as array. Everything you do in NumPy, mostly, almost 99%, right? Or 95, probably. But yeah, we have our matching output to be 5, 7, and 9. Okay? So we have that. Since we have that, let's move forward to step 2, which is initializing weights. All right, how do we initialize weights here? I'm going to need this one. Let me call this data sets. And I will call this one what? Let me call this one initialize weights. So how do we initialize weight here? We want to do we'll call weights is equals to np.zeros, all right? And we go x.shape, and we are just going to pass 1 there because we need the columns, right? So here, basically, let's what you might be asking question, what is weight? So weight controls how important each feature is to the prediction. Does that make sense? So weight basically calculates or controls how important each feature is to the prediction. So we have a 1 right here, which means we're catching out all the features, right? And we are just setting them randomly to start with 0. You can give it any number, but just keep it simple right here. And this np to 0 is basically what we need to initialize or make each of those features to be, just make them 0, right? Because we want to start with random, we call them random. Here we're starting with 0, which is cool. Now imagine your weight as somebody who's dumb. You just give birth to a baby. Every baby being given birth to don't know anything. They're starting from 0. And now eventually as they grow, they kind of learn how to pick something from the floor, learn how to do all that. And then their brain is expanding and it's like, oh, everything is clicking. Their brain is no longer 0 because now they know how to do some things, right? All right. With that being said, that's how you declare or initialize weight. All right, so now let's get to making prediction. How do we make prediction here? I mean, it's kind of like simple, or maybe not. Let's go. So let's call this, I'm gonna call this prediction. And I will call this ypred. That's usually most of the time. That's what machine learning, that's what we use. But yeah, I'm still going to use that right here. And we're going to call the features, set that, we're going to times that. If you watch the tutorial, you'll know exactly the meaning of that act, what it means. We're going to times that by the weights. But what are we talking about here? So predictions are computed using matrix multiplication. So remember, we have the matrix. This is our X, our data here. Our data set X inputs, and then we are getting our prediction by timesing that with our weights. All right. And we did that in our previous tutorial where we had something like this, I think. So yes, this is it right here. The previous tutorial. We had a prediction. We pick our features and we times them by our weight to get our prediction right here. The same thing we're doing here. We pick our features and we times them by the weight, and we're getting our predictions right here, right? Does that make sense? So this combines feature with weight using, the dot products. This is what that sign means. But if you want to understand this more, like I said, just go to the previous tutorial. All right, let's move forward. All right. So what's the next step here? The next step is to calculate error. And I'm going to tell you what this means in a bit. Let's just kind of like write the code first of all. So let's say we have an error, a variable called error here, and we go with our right prediction. We have up there minus our y, which is our features, right? Which is our output, sorry. And so now, our matching outputs is being minus from the prediction, and that is going to give us our error. Now, what does this mean? So error measures the difference between prediction and actual value, right? It measures the difference between, your prediction and your actual value, right? Your actual matching value. So, and each value shows how wrong the model is for one data point. So, for this particular thing, whenever this is computed, it shows how wrong the model is for one data point. So, we don't just stop here. The next thing we're going to do here, after we get this value, we have to calculate or compute the loss. So, that takes us to the next step. We have to compute the loss, and I'm going to tell you why we need to do that, right? So the loss condenses all error into single number. So it takes all the error that has been given for each of this matching output. It takes all the error and put them as a whole number, as a one number, right? So what does that look like? Let's call this loss as a variable, and we have np.mean. I'm going to explain in a bit. And we pick up the error we got earlier and we squared it. This is a squaring right here, right? So if we say loss condenses all error into single number, this is how we calculate that here. We take the mean. We use mean squared error to penalize large mistakes. So if the mistake is kind of like too large, we kind of like use the mean squared error to kind of like try to bring it down, right, from this particular loss. So this is just one function for mean square error. It's actually one loss function that we have, or it's kind of like one of the most used, actually, the MSE. You're going to see it a lot in your journey, so just take note of how it works here. All right, so this is how you actually calculate or compute the loss. You take the mean and you square the error, right? That's what it is. Now let's move forward. Now, the next step we're going to have here is the graded descent. Now, I'm going to take some time to explain this because this is where a lot of people get it wrong. Now, before I start explaining this, I want to tell you what is actually graded descent. So, graded descents are just weights in small steps to minimize loss, right? It's just steps. It's just some steps to make sure that we are minimizing loss. The model is not making a lot of mistakes. We're just minimizing or trying to bring it down and control it. Now, let me go in detail about this. So, loss actually tells us how the model is wrong, right? So, but gradients tells us how to fix it. So this man right here tells us, oh, this man is wrong by 98. Remember, we talked about it sums this error to become a whole number. Now, if the whole number is 18, this man is going to tell us, oh yeah, you guys lost 18, but gradient descent is smart enough as an algorithm that tells us that, okay, you know what, it's 18, you know what, let's actually improve this. Let's improve it. Let's make it better. Or let's kind of like look into it, right? Should we make it up or just bring it down? But yeah, so why do we need this gradient descent? So changing weights blindly would not work. If we're changing weights blindly, remember we randomly initialize weight up here. Let's say the weight is like, just like we have is 0. And eventually when this is run and then the next loop, it becomes, 8. How do we know if we should go down or go up or, that's what gradient descent is actually doing, right? So let's look at the formula of gradient descent. If you look on the screen right now, you're going to see that you have gradients equals to 2 all over n, and you have the transpose of your future y predict minus the actual matching output. Does that make sense? So this formula right here computes one gradient per weight. I want you to get that. We are going to get into the loop section. When we get into the loop section, you understand better that this is going to be run a lot of times for us to get to where we need to get to, right? But I just want to, write the formula down. Just like you see the formula up there, we can put it into code. How do we do that? Just call your gradients. And we'll set that. Remember, the formula say 2 all over n. So here we have 2. And we divide the number of our matching outputs, and we're going to times that. Remember, we have in a formula times. We're going to times that by, we're going to times that by X, we're going to transpose that. It's very good for you to transpose so we can get all the matching features, so we can map to each and every one of them. And we're going to use the dots, the dots multiplication here, and we go with the error, the one we got up here. So that's basically what our formula it's telling us up there, and we just represented it. This is in code, actually. So the error here you're seeing, the error right here, computes, or should I say captures predictions mistake, which is what we have here, right? This is a prediction minus y, right? It kind of captures the prediction mistakes. This transpose you see here, what this does in reality is, or under the hood, no, not under the hood here. What this does literally is align such features with its error contribution, right? It takes it and just align, the features with the error contribution. That's what it does here. It just times the both of them. So it takes each of the features from this man, right? And just times them with the error, right? Does that make sense? All right. So for this particular one is calculating the average and scale the gradient. This is what this is doing here. All right, so that's how you basically get your gradient descent. All right, with that being said, once we get that, the next thing we want to do here is we want to update the weight. How do we update the weight? Now that we have a gradient descent, how do we actually update the rates? There's something we call learning rates. You're going to be seeing this a lot in your journey to becoming an AI or machine learning data engineer. So here we're going to have 0.01. This is just more like everybody does it. But of course, if you're doing in math, the deeper math into this, we would understand really how this works. But we can adjust this up or lower. But hey, I'm just trying to go basics here so we don't I just don't want to overcomplicate stuff. So if you are actually watching right now, just keep your learning rates to be 0.01. I'm going to talk more about this later in the future. Okay. All right. So how do we update the weight here? So I'm just going to call weights, and I'll just minus that. Sorry. I'll minus that from I'm just going to say, I just want to keep reducing the weight. Okay. What I'm going to do is call our learning rates. And, sorry about that. I'm going to times that by the gradient. All right. So that's what we have here. So this minus it from the weight. Keep each time in each step, just keep minusing this from the weight. Do this, minus it from the weight. Do this, minus this from the weight. The learning rates times the gradient descent. Now, some of you might be wondering, what does this mean? So what we're doing here basically is like we move weight opposite the gradient. So I have the minus here. We move it opposite the gradient. So the learning rate controls, this learning rate you're seeing here, it controls the step size. So if it is too big, it's going to overshoot. Boom. If it is too small, you don't want to make it too small. You don't want to make it, too much 0, 0, blah, blah. You don't want to do that. You don't want to make it this. That'll be too much. That's why we start from here. This is the safest one you can start with. Okay. And, let me just kind of like explain, give a real life example. So just imagine a blind man trying to come down from a building, right? We have the stairs, and he's holding a stick and trying to come down. So his eyes is closed. He doesn't know what step to take. He's blind. Now the height from the up to the bottom is the loss, right? Now the slope, which is the stairs, is the gradient here. Is the gradient. That's the steps. The stairs, not the step, the stairs. Now, if that man is going, he's going to use a stick. Just imagine the man using a stick and trying to touch the floor to see which step he's going to take. And he puts his feet gradually into the next step. Now, that step right there is your learning rate. Right? Now, that's why we say if your learning rate is too much, you're going to hurt yourself. But if it is too small, let's imagine the man has just keep putting his feet all the way back and scared. The model is going to be too slow. So you want to be careful whenever you are setting a learning rate. It's very important. All right. With that being said, why do we actually use the X, thing? Let me go back to this one. Why did we use, this transpose right here. So each weight corresponds to one feature, just like I said earlier. From the previous part that we used it. Let me see. Yeah, each actually, the reason why we use this ST right here is because each weight corresponds to one feature. It works by each feature. So a feature that causes large errors right here, we get a larger update. And if there's any one that's too small, it can just, change less and just make a small step and all that. So with that being said, it is time to finally get into the loop, right? So all of the steps that we've been creating, let's put them into a loop, because the machine needs to go over the data to understand them so that they can be able to predicts very well on the data that they haven't seen before. So, right. And we're going to use that, loop to do that. So let's come here and say for epoch in range, and I'm going to set that from 1 to 100. I want this to run from 1 to 100. Now you might be wondering 101, what does that mean? I'm just putting 1 ahead of time because he starts from 0. Okay. So with that being said, what are we doing here? We're going to call the Y prediction. And we're going to set our Y predictions just like we have it up here. You see it right here? We're going to make our prediction here. This is a loop. We're going to make the same thing. We're doing the same thing over. It's just that we just want to run them in a loop so they can keep giving us our value. Now, once we do that, we're going to get our error, which is what we've done up here already. I'm just going to take this one down. We're going to get our error here. As a matter of fact, I can just copy them so you don't think I'm doing something different. What's the next one? The next one is what? Our error, right? We're going to get our error right here. Oh, we did that already, right? We're going to get our loss, compute our loss right inside the, for loop. Put it right here. And what else? We are going to get the gradients. That's the next one. So we are basically, all the steps I've shown you, we're just putting them in a loop so that we can train our model for 100 times, run it over 100 times so you can understand the data, right? All right. So with that being said, we're going to, after we have that here, we're going to run our weight here. And just like we have it up here, we're going to set our learning rates. Learning rate can be set above. So we're going to leave our learning rate up there. We're going to leave our learning rate so you can just use that learning rate. We don't have to put the learning rate inside the for loop. So we're just going to skip that. All right. So with that being said, just to see things on the screen, we're just going to go here and print some things so that you can see train in real time. So if you already use the Python, you know already what I'm doing here. I'm just trying to make sure that for each time it goes 10 times. I don't want to view the whole 100 on the screen. No, I just want to go by the batches of 10. So I'm just going to go, if epoch is equal to 10, I want to print what the result is. I'm just going to go here and use a format and say epoch, and I'll print out the epoch, right? All right. Another thing I want to print out here, which is the most important one, is the loss. We want to see how much less error is our, model performing. So here I'm going to have that, and I'm going to have the loss. Let me bring this forward a little bit so we can have it same. And, I'm going to have the loss here, and we're going to say loss, and we're going to set that to 4 decimal point. Right? And with that being said, what else are we going to print right here? Should we print a weight? I don't think that's necessary, but let's print it because we need to see it as well to see how it grows and how it comes out. So, we have our weights, and we can say our weight is, weights, and we're just going to print next line here so we can have it neatly. All right. So with that being said, we are going to run our, model. It's kind of ready. Linear regression is all ready. So in the beginning, we can see right here, we have imported our NumPy. And next thing we did is to create our data, our features. We create our, matching outputs. And we initialize our, weight here by, initializing them with zeros. You can initialize them with anything, but right here, just to keep it simple, we initialize them with 0. Right here, we made a prediction by taking our features and timesing them by the weight. And we calculated the error here by taking our prediction and minusing them from the, matching output. And, for the computing the loss, here we actually use a mean squared error, loss function. Here you can see that we have our mean from the NumPy, and we take our error and just times it, give it a squared right there. And for our gradients, we just take this half of this and times it, half of our matching total length of our, matching output divided by 2, which is the formula we actually talked about earlier. And we take our, transposing, of our future, and times them by the error to give us our gradient. And to update our weight, basically we need to, learning rate, and, we just keep minusing, reducing the learning rates times gradient from, to get our weight, updated weight. Okay. So with that being said, we put everything inside an epoch, right? We call this whole thing training loop, right? That's what we call it, training loop. So once you have this, we have everything we created up here inside here, so they can run for what? For 100 times here. All right. So with that being said, let's run our code and see what we've got. Alright, so I'm just going to go to terminal, and I'm going to go here and call in Python 3, and I'm going to call in a first machine learning.py, and I'm going to click that OK. Alright, cool. So we can see when we at epoch 10, we have our loss to be 0.3547, and we have our weights right here. You can see 1.0, 1.5. Now when we got to 20, what's the difference between this? This is 0.354. This is 0.288. You can see clearly that our loss is coming down. 0.228, 27. It's still the same with this anyway, but it comes to 60 and it became 26. Okay, still 26 for 70. Oh, we can see it's coming down. 80 is 25, and for 90 is 25. For 100 is 24. So you can see there's improvements. Our model actually is learning from the data that we passed. All right. So with that being said, that's what it's going to be for this tutorial. I hope you understand and you get something from this. If you have any question, put it in the comment section. Don't forget to subscribe and make sure that you change, stuff like if we come back here, like I will always tell you guys, when you learn something from any tutorial, make sure you adjust. Make sure you do different stuff. Switch things, change things. If you come here and put another 0 here, what's going to happen to your output? You want to know why. You want to know what's going to happen. If you look at this right now from the previous one, you can see that we have a large. You can see the loss is large, 29. 16. This is definitely wrong. It's just overfitting, right? This is what we call overfitting, but I just don't want to bombard you with a lot of this. This is just the basics you should know. Practice this a lot, and come back and kind of like change this a little bit. If you change it, what do you observe? Record those things. That's how you learn. You don't just copy tutorial and do it exactly that way. No, just change things. See what results you get and know why, what is what, and what is happening, right? All right. With that being said, I think that's going to be all for right now, as we have successfully trained a model and we changed the learning rate, and we can see it's actually poor. This is not good. This is overfeeding. So yes, with that being said, that's going to be all right now. I'll see you guys on the next tutorial. Don't forget to subscribe. Bye for now.